Cheers, let me just use this so make sure I'm not any random rumbling going on. Cool. So that was all done on these three boxes. So this instrument is a modular synthesizer, which is kind of just a broken apart, deconstructed synth that most people would recognize. You know, something like a Moog Voyager or a Juno or something like that, where you've got keyboard, which we've got something quite recognizable here, and then array of knobs, maybe some settings, but most of the time you assume that you're going to hit a key and it's going to make a sound. It's going to have some sort of preset or tone and patch set up. And a modular synth, all the individual units within the synth are isolated. So you have isolated oscillators, filters, envelope generators, going on to even effects and processors. And it makes for an extremely versatile instrument that can be completely configured. So for instance, last night I walked the dog, sat with Rick and Morty on in the background and put this instrument together. So just picked a set of modules that I thought this will give me enough to work with, and then built this patch this morning. I'm not sure how long Kian was working on his bit.
I did that when we got here.
Good, okay, good. So you can get really interesting results that, if you blag it and look like you know what you're doing, it can look really polished. So it's you can look legit, even though it takes a minimum preparation time. So this piece that we did, it was very sort of free form. There were some rhythmic elements, like I was triggering parts from. There was a cable hanging around my neck, so that's like a conductive sensor. So anytime I pinch that, it's giving me, some sort of randomization of rhythmic kicks and patterns. I had that sort of repeated and looped in a delay, and then all the chordal stuff was triggered manually from the keyboard. And so it's kind of the way that I perform in these instruments is more akin to jazz, where it's more freeform. You're improvising. If you're playing with other people, then you can listen more, depending on how you've got the piece set up. But it transfers into a lot of different genres very well. A lot of techno guys use it. Like most of the guys that I teach sound design and synthesis to, they're all techno heads. So they're coming in. It's like, how do I make a riser? How do I make a this bass line or this kick? And the way I teach is all on modular, not necessarily on this hardware, but there's a good range of even free at this stage software plugins, VSTs or open synths. Eurorack is a good one, in case anyone is familiar with that. And it's a really good teaching tool for learning synthesis from like a lower level, because a lot of the times I think a lot of people they play it safe with keyboards. They'll just flick through presets until they find something that's in the ballpark of what they want, which works fine. I mean, that's how the 80s was done. The DX7 was released, and it's just a nightmare to program on. So people just use the presets. And it's like, I'm using this sound for this part of the track. It's in so many Michael Jackson records, and you can hear it. You can just flick through the presets. Like, oh right, that's Thriller. That's it there. That's all they did. Just hit a key, and they've got the introduction to Thriller. But I think it's kind of a resurgence back to hardware, analog, modular, where you can really customize the instrument, and it's a physical interface. I think compared to clicking, pointing, typing in precise values on a VST, it lends itself to lucky mistakes and a lot more interesting results. I've got a few friends that I study with they're based in LA. So there's a good friend of mine who I used to gig with who. He couldn't tell me, he was under NDA, so he couldn't tell me what he was working on, but he does everything with modular. He's got an ARP 2600 and racks of Eurorack modular stuff. And turns out, now that's out, he did all the sound design work for the Venom movie, which I've still got to see. I mean, I think the reviews were mixed, but the sound design will be top notch, because it's all modular. And yeah. So I need to check that out, but it's all over Hollywood, it's all over so much of commercial pop these days. Even I mean, it's a lot of pop groups that have a producer. Good example is Rick Simpson, he's worked with Coldplay since their second album, I think. But he's big into modular, so I don't know if he does it. I think he does stuff under a pseudonym, like performing on Eurorack stuff. But it's in his studios. Like he uses racks of the stuff just as seasoning, icing on the cake, like just to sort of add bits of unique elements that you could get through a VST, but I know it's riskier that if you're just sampling something from a preset from a plugin, how many other people have just downloaded a plugin and just flick through, oh, that's cool, I'll copy that in. Sure, like you've had this experience where you're pushed for time, putting a project together. I remember one when I was using Reason and Cubase, and just pulling in all the top level samples and stuff like that, and it just ended up sounding like everyone else's project because everyone did the exact same thing. So okay, I'll just use that. I've got that drum synth, I've got that pad, and it's easy to sort of arrange and get an arrangement down quickly. But if you dig in more and start to build the sounds from scratch, okay, I want a kick drum, synthesize it from scratch, then no one has that sound at all. So you've got a lot more unique character to what you do. It's a bit of background on who we are and where we got into this. Way back, I studied at Perth College, did the music performance degree, and that was just straight guitar, drums, and acoustic instruments. So it was a long time until I fell down the path of sound design. But then I moved over to the US and studied out there, got into production, eventually into sound design, and took some weird classes that were like circuit bending or introduction to C programming, and just started dabbling. So there's so many devices like Arduinos, Raspberry Pis, like these sort of like hobbyist platforms that are at this stage, it's the same as it's a quad core processor that you get in your phone that is faster than the PC I was using, even 5 years ago, 10 years ago. So I got into it just by hacking and circuit bending, like buying old toys from the 80s that are just like little analog chips and circuit bending them and turning into weird instruments. And just before graduating over in the US, I co-founded my first company called Cubit Electronics over there. So designed a module that was entirely based around the Raspberry Pi computer. So we just had one of these off-the-shelf stock computers, bolted onto the back, and running a program called C-Sound, which is an open source sound engine that looks hideous. It's like it's syntax based, so it is the most versatile modular synth in my opinion. But to connect oscillators, you need to write, okay, I'm going to load in this opcode, and then you've got a string of functions. So it's all, you look like you're full on computer programming. It's a simplified language, but it is still a pretty gnarly syntax that you need to learn. But it's open source and entirely free. So we got that running on a Raspberry Pi, so it would just sort of automatically start up. You wouldn't know it was a full computer running on it. It was running the sound engine and a co-designed sample player. So this was one of the first sample player modules that would fit into the Eurorack spec. And we sort of hit a gap in the market. So this first product sort of went viral, and it just built upon that and just kept going and studying and learning. And so I moved back to Scotland about 3 years ago. No, longer than that. Yeah, about 3 years ago. And started up Instruo, which is this new company, and just most of the time I'd been spent analyzing analog circuits and just researching. So like all the classic synths, like the early Moog stuff, Buchla stuff, ARP, EMS, when those were released in commercial products, they'd publish a service manual that came with it, because if the thing broke, you'd need to take it somewhere to get fixed or dig in with a soldering iron and fix it yourself. So all the schematics for these synths are public domain. So they're all out there just on the internet for anyone to download and look at. So that's literally what I did, just download them. The first filter that I did, which is this guy here, you can see it on that's not sounding very well. But it's basically a direct rip of the Minimoog filter, the low pass filter that's in that circuit. So I just used that schematic, rebuilt it using modern components, which are much cheaper and much more stable these days than when Moog was building them. And most of the designs that I do, I tune by ear, and I'll get it to work. So okay, it's filtering sound, but the cutoff frequency range is like way up, beyond what I can hear. So it's just a case of fine tuning and trial and error. So the way that I approach designing stuff, it's from the music background, because the engineering side I've just sort of learned from YouTube, and sitting on forums getting shouted at by people that are just really reluctant to answer questions nicely. But it's, I found that's been an interesting approach to designing, and I've kind of learned the business side of things and how to bring a product to market, what I need to do, where to source components, how to set up assembly lines and stuff like that. And I've kind of just learned those things to supplement the process of creating a module, creating a musical instrument. So it's only now I'm at the stage where I've got enough range of products that I can perform on a full system of my own stuff. And since Kian joined the team about a year ago, we met at like a DIY synth thing in Glasgow and kept in touch and started bashing about ideas.
Yeah, and I started here actually. I did HNC and HND at Commonwealth, and then went to UWS to do the music tech BSc, and then wanted to get into kind of making music and using stuff that had no money. So started like DIY and stuff and doing like building guitar pedals from kits, and there was a book called Handmade Electronic Music that's got loads of like free stuff you can do to hack FM radios and stuff like that. And then started going to this kind of DIY synth group, and met Jason, and then like a few years later I'd started building Eurorack, and I was building them to sell modules so I could
fund your issues.
Yeah, basically I could never afford to buy these things, so I would build two, sell one, and then keep one. And then got in touch with Jason when I realised he'd set up a company, and said, how do I get your job? And just invited me down, and we started working together.
We made that.
This was our first design together. It's like
I can zoom in a bit.
A synthesizer that's biofeedback, so it was designed to work with plants. So you get these little sensors with it, these sensor cables, and you put them onto plants. It was like technology that was developed in the 70s, years ago. And that you could then use plants to control synthesizers, but it outputs MIDI, so you can control like lighting or effects or video things. And I was using one of these with a box like through several different things in order to use it to kind of play synths. So we wanted to put it together into a module that we could use, and then we worked well together, and it worked well, and started selling it so I could stop working in kitchens and building synths full time. And now we've worked on a bunch of modules together. I think we tend to put them out at a slightly unhealthy rate of kind of 12 modules a year or something, which is faster than we can sell them or finish them. We just kind of get excited and move on to new ideas.
Yeah, which it's not following the rule book of how to do product releases or product development. So I think we'll have an idea, and the process I've developed over time is pretty quick. So I can turn around, first revision prototype within a couple of weeks. Send the files off to China. The boards come back a week later. We spend a day or two building them and see if it works. So we're kind of road testing all the designs as we go. It's only with a couple of new ones that we're actually going to force ourselves to go through like a beta test phase and send them out to a few like modular artists or sound designers to get some feedback. It's like, does this make sense? Or are we just living in this weird bubble where it's like, that's totally cool, but it's not got any real world use. But yeah, the business side of things, I don't know how to do that. I'm learning as I go. But people seem to be buying the stuff, so we'll keep building them. And it's recently we've started teamed up with Rubadub. That's the store at the bottom of Buchanan Street that sells. They're a record store originally, but they sell like DJ equipment and now a lot of Eurorack modular synth stuff. So they are now acting as my distributor, which is great because it means that I build them, just drop them off at their door, and it's their problem. They track down the stores that source them all, which is good. So this is like, the last few weeks we've kind of been going through this first, scale up and figuring out how to how to keep track of this larger stock. So we've got a string of the new designs that are just sitting waiting to be built that we're keen to get onto, but we're kind of stuck building the older ones. So
originally it was kind of, we build something and then take a photo of it and put it on Instagram, and then someone would email us and we'd build them one and send them one, and that would kind of pay the rent, and you'd sell maybe half a dozen of each module, build them in small batches. But yeah, being able to sell through shops means that now we don't hopefully have to deal with customers less.
Yeah.
And that was kind of as far as our kind of marketing went, was like the odd kind of Instagram post, and then that would give us enough work to keep going. And so yeah, we've done absolutely no marketing or advertising beyond that whatsoever.
Yeah, I think my last Instagram post was 4 months ago.
Yeah. but yeah, now they're in shops around the world, so hopefully the shops will do the rest of the advertising for us.
Yeah, so that's what we do, and a bit of the sounds of what the things is that we make that they make sense to do. That's, our band name is something along the lines of, we started performing more together as a two-piece. So the first gig we did, the official artist name was We Make Sounds with the things that we make to make sounds with. It just rolls off the tongue. Everyone got it wrong. I don't know how. Yeah, so it's online. If you search for that, nothing will come up because they got bored halfway through typing. So
We Make Sounds.
We Make Sounds, yeah, which is accurate, I guess. Anyone, any questions?
Just in case there's some people that are thinking, A, what is Eurorack? And B, if this looks cool, what do I need to get, apart from a big wallet or some
soldering iron?
Soldering iron, yeah.
Exactly, that's it. But yeah, what do you need to hook this sort of stuff up?
Yeah, so Eurorack is the name of this particular format of modular synth. Like the original synths that were built were like the Moog Modular, which were 5U they're referred to. So I guess U is the it's a rack unit. So a 19-inch rack unit. So 1U is like one of those standard units that you mount in. So these are 3U, which is basically 3 units high in height, and the original modulars were 5U, so they were quite a bit bigger, quite a bit deeper, and cost a fortune. So
every company had their own specifications because they all made them separately.
Yep.
So every company made these different synths, and you could only play, Moog synths with Moog synths and Buchla with Buchla, and then a guy called Dieter Dopfer, was it in the 90s?
Late 90s, so it's a little over 20 years ago. A German developer created this newer standard, which is a bit shorter, and standardized the power supply and just opened the spec. So it was published so that anyone could customize their own designs to fit into a Dopfer modular system. And it just kept going and building, and there are now tons of companies, small companies, yeah, something like that, all making modules that fit in. So it's a standard size, standard power supply, and standard voltage connection. So it's all control voltage and analog control scheme for communicating between the modules. So it's becoming the most versatile hardware synth. As for getting started with it, you can pay as much as you want for certain things. It can be done on the cheap. Like there's a big movement that sort of grew with it of synth DIY. So there's a lot of modules out there that you can buy for 20 or 30 quid for a kit. So it's like the circuit boards, all the components. If you have a soldering iron, you can assemble it all. There's great support and documentation online. So you can build a pretty substantial system on a bit of a shoestring budget. I mean,
I think there's like a bit of a hurdle at first. So if you've got 200 quid, say, you could buy a kind of like a pre-built synth, and you'll get more functionality than you would Eurorack, because you'll have to buy a case and you have to buy a power supply. But once you've got a case and a power supply and a basic thing, then for not much money you can keep adding to it and keep adding to it. And the thing that makes kind of the reason that Eurorack was so successful is, in a modular synth you can plug anything into anything, so it makes it really flexible. So everyone plays in different styles and different sort of different ways, different genres of music, and the instrument can be bent to to play in any way. But with Eurorack, you can plug any manufacturer's instrument into any one, and then quite quickly you end up with this complex machine. Like, so I've played with this past year, I've been playing with this small box, and I've just never run out of ideas of things I can do. I could play, you know, solo sets for ages and still find new things out of it from just a tiny box. So you don't need to have, people have like huge systems because, you know, they have lots of money, I guess, but you don't need much. And you can really do loads with it. But yeah, learn to solder and it's much cheaper.
Yeah.
Components don't cost much, you know, and PCBs don't cost much. But, you know, paying someone else to build it for you costs money.
Cool.
Could you maybe talk us through like the design sort of journey, I guess?
Yeah.
From an idea to maybe prototype, and then how they come to be. Because obviously you're talking about PCBs and
Yeah.
components and stuff, and I wonder maybe everyone doesn't know what does one of them look like inside? What's behind the face?
Let me grab a screwdriver. I'll pull one of these modules out and show it up on the camera. Here we go. So the early modules I got, actually I found them in a box the other week, and it's just this. It's awful. It looks. I don't know how it got back into the country because I had to get it shipped over from the US because it was in storage, and it just looks like
A bomb.
Yeah.
A really badly made bomb.
Yeah, it's just like, you know, bits of cardboard and plexiglass and pots and wires, everything. It's just this like mess of stuff hanging off. So my original prototype process was I'd start with, you know, the circuit, the schematic that I was referencing and rebuilding from, and I'd use what's called a solderless breadboard. So this is a sort of like plastic, you know, mini like patch bay thing that you can hook up, you know, power supply wires. So you'd have your plus 12, minus 12 ground, 5 volts if you need it. And you literally just like push the integrated circuits and resistors, capacitors, and you build the circuit on this solderless breadboard. So it means that you can use jumper wires and just patch it together, and you don't need to solder anything. So you can really quickly try it with a different resistor, try it with a different capacitor, and experiment and improvise with it. And so that would be my first step, and you'd end up with like, you know, a desk like, you know, half the size of this that is just the circuit spread out over this massive breadboard, which doesn't, you know, gets quite inconsistent because a lot of times you just flex one wire and that breaks everything. But going from that step, once I'd confirmed that the circuit does what I want it to do, then my original next step was to build a more solid version that I could actually road test. So I'd get what's called perf board. So it's like, you know, those circuit board strips that's just a big grid of holes and then just like copper links on the back. So you could then put the components on that, solder it together, and build the physical circuit so that it could, you know, withstand a bit of road use. And, you know, the original faceplates that I used were, you know, I think the very first one was just a bit of cardboard that I could screw into that and then just like punched holes through it and just had the pots sticking through it. So not very sophisticated, but it did the job. And so that would be like a soldered, like constructed version, which is the ones that I found in the box. The next step was to learn how to draw circuit boards and get them fabricated as PCBs, as printed circuit boards. So this one, purple, so this is from an earlier batch that I got the boards fabricated just raw in China and sent over, which can be done for not, you know, they don't break the bank. There are a couple of software programs that I used. The original one was called Fritzing, which if anyone's familiar with Instructables or different like DIY tutorials, a lot of like the Arduino tutorials, there'll be like goofy little cartoon drawings of the capacitors, the resistors, and how to patch it together. It's made with that program. So you end up, you draw the schematic virtually with like all the components that are in a library, and then you switch over to a board view, and it's basically, it's just a CAD program. It's like Illustrator or AutoCAD. I mean, the program that I use now is actually run by Autodesk, who do AutoCAD and stuff. So it's like, there's a lot of like really good growing support. And once I've got the schematic drawn, then I switch over to this board view and I can place the components on on a flat sheet, and then it's a case of just drawing and linking up all the parts. So you see there's like darker purple bits in and around, and all the lighter ones, those are copper traces. So they're the actual wires. So the first run, it would be all these chips, but probably bigger versions of them, and then all the circuits actually hand wired, which takes forever when it's this dense, this many different parts. But with a printed circuit board, I can do that ahead of time. So I choose the footprints that match like the certain versions of the components I want, and lay it out. It gets fabricated, and then it's a case of soldering all these chips on. So these ones are all done by hand in the workshop, which there are tricks that I've picked up over time that speed it up considerably, but it's still a pretty slow process. And yeah, but that's this stage now. I don't go through the breadboarding phase because so many of the circuits that I've used, I've already built them. So I've essentially, I do hardware the same way that most software engineers write software, where they'll have functions or libraries that they go to. So I've got a backlog, a library of, okay, that's an oscillator core that I can use. That's a voltage controlled amplifier. That's a filter, and I can just compile and remix different designs. So if I've got an idea for something that I need, it's like, okay, well, we need an audio input into a delay unit. So how do we want to do that? Do we want to go in direct? We could use the same way that it was done in that module, or we could try something new. And that's what sort of over time things have got quicker and quicker each time with designing a new prototype, because I've got a lot of stuff to reference and refer back to. But I mean, a lot of this stuff I'm still learning. Like looking at the original schematics, it's only quite recently, like some of the main ones I've been using, the oscillators, the filters, these are all based on older existing schematics, like from this public domain archive, and I'm now starting to understand them more. So I've basically been learning that side of it as I go. But the focus that I had to do was learning the software to be able to do it. So learning it's called EcoCAD, which is Autodesk. So it's free if you download it and are a student. Then you've got the full package that you can run for free. There's a bunch of good YouTube tutorials out there that get you up and running with how to use it, and an ever-growing support network through forums and stuff like that for it. Yeah, that's kind of the hardware side of how I got into the designing. The actual the creative side of I've changed over time from kind of doing what I guess is the more standard model of product development, where it's like, okay, what can I make that will sell and make me millions? And so many times I've done that. I'll design something and it ends up like with feature creep. So there's one point I designed a sequencer which is still in the market and doing quite well, but there's so much time put into that, different revisions, and it ended up with so many additional features. Like you could store banks of sequences, you could then sequence through these different banks, and it was menu diving because there was no screen on the thing, so it was like button combinations that you'd need to memorize to be able to use it. I knew them, of course, because I'd coded it, but giving it to a beta tester, I was like, so how do I do that? It's like, oh, you press that button there, and you're in that mode. But that doesn't translate so well to being a usable musical instrument. So I sort of learned from that process over time, and the first module that I designed as Instruo for this new company was the Troika, which is a module over here, which is quite a big one, and it's just 3 analog oscillators. So it's kind of like the equivalent of the oscillator part of the Mini Moog, where they're just free running. You can track them together, so you can control them with the same pitch, and then they'll all follow, and you can sum them together and get really warm, fat, subtractive voices. I designed that one for myself because I'd been experimenting with that circuit before. I've got the prototype working, so I could build an oscillator, and built in a way where each oscillator's got the 4 classic waveforms: sawtooth wave, square wave, sine wave, triangle, and I used analog crossfaders so that I could then interpolate between a sine wave to a sawtooth wave. So it's a bit of variable degree for how much harmonic content's in it. So at the starting point, there's a lot of versatility in the tone, but it's big. Like the layout is goofy compared to previous designs, which were more like they're deeper in feature sets. So this one, it was just a bit more basic. The knob, everything was spread out more. It was using bigger knobs, and I didn't expect that to sell because it's an oscillator that is like the most basic building block of a synthesizer, and every company in the format has an oscillator. So I made it for myself, did a video of it. Like I actually documented the drawing the schematic, laying it out, building the first prototype. So I produced that as the nerdiest music video ever. So I did a modular track, and then it's like 15 minutes of a time lapse of schematics getting drawn, and then boards getting traced, and then brass getting At the time I was using a CNC machine to mill out my own faceplates. So it's it was like a time-lapse documentation of the video, but that I put that out and got a lot of good feedback of it. I think people liked the fact that they saw the process. So whereas if a company releases a new module, you go online, you go into the main forums, and immediately it's people saying, "Oh, why doesn't it do that, or does it do this, or why I don't get it." And I think it's that disconnect where it's something new, and immediately they're trying to match and see where it fits into their system, their workflow. But it's just a picture. Like they don't have a context of it. They don't have a relationship with the product. Whereas I think that video that I put out, people saw the entire thing. They saw the whole thing built from scratch and saw the work that went into it. So immediately it dissolved that side of it. So I didn't see any of those sort of comments. I didn't get any of that feedback. So, why doesn't it do this, or why didn't you add a fourth oscillator? And it was people got in touch and were trying to buy it. I was like, well, I only have one, only made one. So I then had to backtrack, and it's like, okay, well, that wasn't my plan. I was planning, this module to be like the first available product, but I guess there's a market for this first one that I didn't intend. So that kind of steered me into that direction. That sort of recalibrated how I thought about what to focus on. So at this stage, I've kind of decided I'm not going to design based on what I think will sell, what I think people will want. And the approach I'll take is I want to make the module that I want to add to my system for, a new album concept that I've got, or a new synthesis technique or model. And so I basically design selfishly. I make the thing that I want to use and then put it out there, and people seem to be buying them so far. So I'm just going to continue that way. And working with Kian, we've got a growing team in the workshop now where there's just constant ideas bouncing around. It's like, I was reading up on this. We could actually try that in this context. And at this stage, there's so much hardware that's hybridized, digital or analog, that we can repurpose it. We can just write new firmware for it. We can write run a new DSP program on it and road test new functionality, new features for a new module on something that's got close enough control set for it. And
because there's quite a mix. Not all of these modules are analog like that one, where they're just components and things. Some of these are run on Arduinos essentially, so the same processors that are familiar with Arduinos. They're like little. I guess they're kind of starter things to get people started doing DIY and programming things. They come as little boards. They're like 15 quid or something.
Yeah, something like that.
And there's loads of, you can use them to do all kinds of anything you want really, but a bunch of these are based on those kind of really accessible, because it's like coding for dummies kind of first step. And some of these are on Raspberry Pis, which are like similar little single board computers that again cost like 10 or 15 quid, but there's a whole like operating system on this module here, which is a new one that isn't out yet, which is essentially like a guitar pedal looper, like just two loop pedals together, but you can change the playback speed and things. But to program that, we plug a monitor in and a keyboard and a mouse, and you get an operating system. It's like using Windows or something, and you can kind of sketch everything out and use software to do it, and then unplug that and put it in here, and it looks and behaves just like a analog oscillator. So there's a nice kind of mix of, there's some things that are better done digitally, which are really kind of easy, and there's some things that are much easier and quicker to do in analog. So there's a total mix across the modules.
Yeah. Cool.
Does anyone else have any questions?
Yeah, we're based in, currently the workshop is in Royston. I don't know if anyone's familiar with Shugle Studios, run by Simon Stokes. It's a big techno scene. So I teach a sound design course there, like as an evening class, I do use a lot of the modular stuff, but I use a lot of software instruments so it means everyone on the course has a full modular system to learn from. So I'll try not to make it too much of a sales pitch. It's like, yes, well, this one sounds like that, and you can buy it for this great deal. So I try and avoid that as much as I can, and just teach it as a musician more. And but yeah, if anyone's around Glasgow in that area, then get in touch. Come round. Simon used to come and work and build for us down there, so we've not seen him for a while. So.
You've got currently one of our H&D students working for you as well, don't you?
Yeah, I know. Yep.
Showing us up, making us look
He's very quick. I'll show him how I build something. He's like, okay, so I do this order, and within like 10 minutes, he's come up with a more efficient way. I'm like, I feel like a moron now. So yeah, always learning. Cool. Well, we'll be here for a bit, so if anyone wants to come up and take a look, have a shot, and you're most welcome to.
Okay, great. Thanks, guys.